Take off your shoes right now. If you can't, just picture the bottoms of your bare feet pressed flat against soil, grass, or the cool surface of real earth. Hold that image. What I'm about to explain is happening through that exact contact point. Almost nobody who tells you to touch grass can explain what is actually moving through your skin when you do it. Here's the claim, stated simply. The surface of the Earth has a measurable and continuous negative electrical charge, between -100 and -400 millivolts compared to the outer atmosphere. This charge is constantly replenished by around 1,800 thunderstorms happening somewhere in the world at any given moment. When you wear rubber-soled shoes, walk on synthetic flooring, or stay in elevated buildings, your body becomes electrically isolated from that surface for most of modern life. The moment your skin touches soil, grass, sand, or untreated concrete, this isolation ends. Electrons start to flow. Not metaphorically, literally. You can measure it in volts using a multimeter clipped to your ankle. This is the physics that nobody explains, because it sounds too strange to take seriously. The people who first measured it were dismissed as fringe for a long time. We'll discuss them later. But first, let's explore the mechanism, layer by layer. We begin with the simplest part. What is actually in the ground beneath your feet? Electricity-wise, the Earth is a huge reservoir of free electrons. This isn't just poetic language. It's what geophysics literally says. The planet's surface and the ionosphere, roughly 60 to 1,000 kilometers above, form what's known as the global electric circuit. This concept was discovered in its current form by Scottish physicist C.T.R. Wilson in the early 20th century. While working at the Cavendish Laboratory in Cambridge, Wilson proposed that thunderstorms act as the planet's charging stations. Each lightning strike sends a negative charge into the Earth's surface and a positive charge upward into the atmosphere. This maintains a steady voltage gradient of about 100 volts per meter between the ground and sky during fair weather. Thus, the ground sits at a stable negative electrical potential, constantly replenished by storms occurring around the globe, day and night, regardless of the weather where you happen to be. Wilson didn't reach this understanding by chance. He spent years developing an instrument called the Wilson cloud chamber to visualize the paths of charged particles. For this work, he shared the 1927 Nobel Prize in Physics. His keen focus on charge and ionization led him to the global circuit hypothesis. He observed something that seemed contradictory at first. During fair weather, without a storm in sight, the atmosphere still maintained a steady downward flow of positive current toward the ground, measured in a few picoamps per square meter. If that current continued, the surface charge of the planet should have neutralized within minutes, but it never did. Wilson concluded that thunderstorms scattered across the world acted as a constant battery, pushing negative charge back into the ground faster than fair weather currents could drain it. Modern satellite and ground-based monitoring networks have confirmed the general outline of his model and have even refined the global thunderstorm count to about 1,800 storms active at any given moment, each contributing a small charging current to the same planetary circuit. A human body is a great electrical conductor. We are about 60% water, filled with dissolved electrolytes, sodium, potassium, chloride, and these ions move charge through us effectively. Bone conducts. Muscle conducts even better. Blood, being essentially salt water with cells suspended in it, conducts best of all. When bare skin touches the Earth's surface, you create a circuit between two systems at different electrical potentials, allowing free electrons to flow from the negatively charged ground into your body. Electrons follow the same basic law that causes any electron to move through a conductor connecting a higher charge to a lower charge. This is the first mechanism, and it has a solid physical basis. Direct electron transfer from the Earth to the body through skin contact. Clinton Ober, a former cable television executive turned grounding researcher, worked alongside physiologist Maurice Galli and cardiologist Stephen Sinatra. Together, they conducted some of the first controlled studies on this in the early 2000s, publishing their results in the Journal of Alternative and Complementary Medicine. They wired subjects to conductive mats and measured changes after grounding. The consistent finding across their early trials was a measurable shift toward a more negative surface body potential. This means the body's electrical baseline aligned with the Earth's within minutes of contact. But a change in voltage alone is not a health claim. It's just physics acting as it does. The intriguing part, the part that gives this real biological significance, is what happens next inside the blood. This is the second mechanism, operating through the same contact but on a completely different scale: red blood cell behavior. Gaetan Chevalier, a biophysicist at California State University, Los Angeles, published a 2013 study in the Journal of Environmental and Public Health. He worked with cardiologist Stephen C.T.R to use live blood analysis, dark-field microscopy, to photograph red blood cells before and after grounding. Healthy red blood cells repel each other slightly due to a negative surface charge called zeta potential, which prevents them from clumping as they move through capillaries. In the photographs Chevalier published, blood drawn before grounding showed cells sticking together in clusters, a condition known as rouleau formation, which is similar to patterns seen in inflammation and elevated blood viscosity. After 40 minutes of skin contact with a grounded conductive surface, the same subject's blood showed a significant increase in separation between cells. Chevalier's team calculated that the average zeta potential increased about 2.7-fold across the trial. Higher surface charge on the cells led to more repulsion and less clumping. Think about what that means mechanically. Red blood cells that repel each other more strongly move through narrow capillaries with less friction, less aggregation, and theoretically lower resistance to flow. This is not a small or abstract effect. Blood viscosity is a recognized factor in cardiovascular strain. Reducing red blood cell clumping is the same outcome targeted by some anticoagulant therapies. However, this is achieved through a completely different, non-drug method: an electron gradient absorbed through the sole of a foot. There's another aspect to this electrical pathway involving the autonomic nervous system, which controls heart rate, digestion, and stress response without your conscious input. Maurice Galli and Dale Teplitz conducted a 2004 study, published in the Journal of Alternative and Complementary Medicine. They had subjects sleep on grounded conductive sheets for 8 weeks while tracking salivary cortisol, the body's primary stress hormone, throughout the day. Cortisol should follow a sharp daily rhythm. It peaks in the morning to promote wakefulness, declines steadily through the day, and is low at night to allow for sleep. Over the 8-week period with Galli and Teplitz subjects, that rhythm normalized. Cortisol levels began to align more closely with the expected daily pattern compared to ungrounded controls. Subjects also reported falling asleep faster and waking with less pain. A separate study by Polish researchers Karol and Paweł Sokol, published in 2011 in the Journal of Alternative and Complementary Medicine, measured heart rate variability, the variation in heartbeat rhythm that reflects the balance between the stress-activating sympathetic nervous system and the calming parasympathetic part. They analyzed subjects before and after 2 hours of grounding. The study showed greater parasympathetic activity, similar to what you find with relaxation training and meditation. Their measurement was based on an electrocardiogram, not self-reporting. The Sokols suggested that the same electron transfer affecting red blood cell zeta potential might also neutralize free radicals and reduce low-grade inflammatory signals throughout the cardiovascular system. However, they carefully called this a hypothesis that requires more confirmation, rather than an established mechanism. Now, the evidence quality here is important, because the grounding research field has a credibility issue it has partly earned. Chevalier's studies often had small sample sizes. The zeta potential study included just 10 subjects. Replication by independent labs not affiliated with grounding product manufacturers has been limited. Some foundational researchers, including Ober and Sinatra, have financial ties to companies that sell grounding mats and conductive sheets. This creates a clear conflict of interest that any honest assessment must acknowledge. The physics of electron transfer between conductive ground and conductive body is not seriously disputed. That part is basic electrochemistry. What remains truly uncertain is the extent of the impact, how much this noticeable voltage change matters for long-term health outcomes beyond small, short-term laboratory trials. The connection makes sense and has some measurements. However, it is not yet proven at the scale that claims come from those selling you a $200 grounding bedsheet. There is another mechanism here, completely separate from the electron transfer story. This one has more substantial evidence, because it is not really about electricity. It concerns what lives in the dirt. Soil is not just dirt. A single gram of healthy topsoil holds between 1 billion and 10 billion bacterial cells, along with fungal networks, protozoa, and an incredible variety of microbial life. Some estimates suggest that a teaspoon of soil contains more individual organisms than there are humans on Earth. Among these organisms is a species called Mycobacterium vaccae, a harmless soil bacterium first isolated from cow dung in Uganda in the 1980s. Christopher Lowry, a neuroscientist at the University of Colorado Boulder, began studying this bacterium after observing something unusual in cancer patients who were injected with a heat-killed version during an unrelated clinical trial in the late 1990s. These patients reported better moods and improved quality of life, regardless of their cancer outcomes. Lowry's lab followed this lead for over a decade. In a series of studies published starting in 2007 in journals like Neuroscience, his team injected mice with heat-killed Mycobacterium vaccae. They found it activated specific clusters of serotonin-producing neurons in the dorsal raphe nucleus, a part of the brainstem vital for mood regulation. This system is similar to what SSRIs target, but the mechanism is different. The bacterium seemed to trigger an anti-inflammatory response that reduced stress-induced inflammation through the immune-brain connection. The mice displayed measurable anti-anxiety and antidepressant-like effects that lasted weeks after a single exposure. Many people completely overlook this. Mycobacterium vaccae is present in ordinary garden soil, untreated dirt, and the grass under your bare feet. You don't need an injection. Disturbing soil by digging, working in a garden, or walking barefoot on uneven ground releases small amounts of these and similar soil microbes, which can be inhaled or absorbed through skin contact and minor cuts. Lowry has been careful not to overstate the leap from injected mice to incidental human contact with soil. The doses, exposure methods, and effects in human gardeners have not been thoroughly measured the way they have in lab mice. However, the main idea, that soil bacteria interact with mammalian immune and nervous systems in ways that reduce inflammatory stress signals, has been confirmed by several labs with different bacterial strains since Lowry's initial work. This research has led to what is now recognized as the old friends hypothesis, proposed by immunologist Graham Rook at University College London. The hypothesis suggests that human immune systems evolved over hundreds of thousands of years in close contact with environmental microbes. The hygienic isolation of modern life, concrete, carpet, air conditioning, and paved surfaces, has deprived our immune systems of the input they have come to expect. This is where the story shifts from one mechanism to multiple layers, showing how a body is designed for an environment it no longer experiences. For about 300,000 years, every human lived in skin contact with bare earth for most of their waking hours, walking, sitting, sleeping near ground level, and working with soil using bare hands. The disruption of that contact is recent enough to measure in decades, not centuries. The production of rubber-soled shoes ramped up globally only after the 1950s. Elevated wood and synthetic flooring, along with asphalt and high-rise living, have cut off direct ground contact from billions of human days that would otherwise have included it. From an evolutionary perspective, the average person today has an immune system, a circulatory system, and a nervous system that were fine-tuned over millennia for continuous low-level contact with soil and electrons. For the past 2 or 3 generations, bodies have almost never received these inputs. Now consider sunlight. There is another layer, and it works through a different organ system: skin photochemistry. When ultraviolet B radiation, specifically wavelengths between 280 and 315 nanometers, reaches a cholesterol-derived molecule called 7-dehydrocholesterol in the deeper layers of your skin, it breaks one of the molecule's carbon-carbon bonds. This transforms it into previtamin D3, which then converts into vitamin D3 itself over several hours. Michael Holick at Boston University fully mapped this process in a series of papers during the 1980s. Vitamin D3 then travels to the liver, where it is turned into 25-hydroxyvitamin D, and then to the kidneys, where another conversion creates the active hormone, calcitriol. Calcitriol regulates calcium absorption, immune cell function, and gene expression at more than 200 sites across the human genome by current estimates. Touching grass generally means being outside in direct sunlight with exposed skin. This exposure results in photochemistry that no artificial floor could replicate. The two mechanisms operate both independently and simultaneously. One is electrical, through the soles of your feet. The other is photochemical, affecting any exposed skin. Lying on grass in sunlight for 20 minutes activates both pathways, which is why the advice to touch grass exists across cultures and centuries that had no understanding of electron transfer or vitamin D synthesis. They may not have known the mechanisms, but they observed that people who spent time on bare ground and in sunlight seemed to feel better. The story changes once more because we have a fifth layer, and this one is not about chemistry or electricity. It focuses on attention. Stephen Kaplan, a psychologist at the University of Michigan, developed attention restoration theory in papers during the 1980s and 1990s. He built on the idea that directed attention, the focus required to read, drive, work on spreadsheets, or navigate phone screens, is a limited cognitive resource that becomes depleted with extended use. Kaplan referred to this depletion as directed attention fatigue, which leads to irritability, reduced impulse control, and impaired concentration. His theory suggested that certain environments help replenish this resource, particularly those with what he called soft fascination. These are natural stimuli like grass, leaves, clouds, and flowing water that capture attention effortlessly, unlike the focused effort required in built environments and screens. This theory was not merely conceptual. Ming Cui and William Sullivan at the University of Illinois Urbana-Champaign conducted studies in the late 1990s and 2000s, published in Environment and Behavior. They discovered that children with ADHD showed significantly improved focus after 20-minute walks in natural green areas compared to identical walks in urban environments. The effect size of this improvement, shown in their 2004 study, matched that of a typical dose of methylphenidate, the active ingredient in Ritalin. The effects were not the same in terms of how they worked, but they were comparable in impact. A 20-minute walk through grass and trees had measurable cognitive benefits similar to those produced by a stimulant medication. There is a sixth aspect here as well, which has nothing to do with electrons, microbes, or hormones. It is purely mechanical, running through the structure of the foot. The human foot contains 26 bones, 33 joints, and over 100 muscles, tendons, and ligaments, packed with mechanoreceptors, pressure and stretch sensors second only to the hand and lips. Daniel Lieberman, an evolutionary biologist at Harvard, published a 2010 study in Nature comparing the biomechanics of habitual barefoot runners to those who grew up in cushioned shoes. He found that barefoot runners typically land on the middle or front of the foot. This distributes impact force gradually through the foot's natural arch instead of sending a sharp force directly through the heel to the knee and hip, as often happens with cushioned heel-strike gait. Modern shoes, which elevate the heel and cushion impacts, change the signals the foot sends to the brain about ground contact. Some podiatric researchers, like Irene Davis at Harvard's Spaulding National Running Center, argue that this dampened sensory feedback contributes to the weaker intrinsic foot muscles seen in people who have always worn structured shoes. These feet are mechanically doing less and have adapted by becoming less capable. Standing barefoot on uneven natural ground forces the small stabilizing muscles of the foot and ankle to make constant micro-adjustments that flat shoes and sidewalks never require. This effect resembles a continuous, low-intensity workout for proprioception, more than just ordinary standing. This is the synthesis point, where all 6 mechanisms converge on the same simple act. You walk outside, barefoot or not, and sit on grass. Electrons move from soil into your body through skin contact. This changes your surface charge and reduces red blood cell clumping. The same contact seems to influence cortisol levels and heart rate variability, moving them toward a calmer baseline. Soil bacteria interact with skin and respiratory surfaces. This triggers immune signaling that reduces inflammation and reaches into brainstem serotonin pathways. Ultraviolet light turns a cholesterol derivative in your skin into a hormone precursor that regulates calcium and gene expression throughout your body. The natural visual field around you, leaves, grass, sky, requires little effort to maintain attention, allowing your strained attention system to recover. When your feet are bare, the uneven ground beneath you gives your muscles a continuous workout, which flat sidewalks and cushioned shoes don't provide. 5 distinct physical systems from various scientific fields come together to support one old piece of advice. This advice has existed for hundreds of thousands of years, long before the science behind it was known. I want to share one more striking element that comes from Japan. In the 1980s, the Japanese Ministry of Agriculture, Forestry and Fisheries introduced the term Shinrin-yoku, or forest bathing, as part of a national public health campaign. Qing Li, an immunologist at Nippon Medical School in Tokyo, spent decades investigating whether there was anything measurable that backed this idea. In a 2010 study published in the International Journal of Immunopathology and Pharmacology, Li sent participants on 3-day, 2-night trips to forest areas and drew their blood before and after the trips. Natural killer cell activity, a measure of immune function related to detecting viruses and tumors, increased significantly. In some participants, this boost remained for up to 30 days after a single trip to the forest. Li identified part of this effect as being linked to phytoncides, antimicrobial compounds released by trees, like pinene and limonene. Participants inhaled these simply by breathing forest air. When these compounds were tested in hotel rooms using forest tree oil diffused into the air, they produced a similar, though smaller, increase in natural killer cell activity. The forest itself affected immune function even days after the initial exposure. Here's what I find truly moving. None of these researchers, Wilson mapping the global electric circuit in the 1920s, Lowry isolating serotonin-activating soil bacteria in the 2000s, Kaplan studying attention restoration in the 1980s, or Li measuring immune cells after forest walks, set out to validate a folk saying. Each was pursuing separate questions in different fields, using tools and methods completely unrelated to one another. They came from atmospheric physics, immunology, cognitive psychology, and dermatological photochemistry. Despite their different paths, they all reached the same conclusion. Direct contact with the Earth's surface does something measurable to the human body that indoor, insulated, screen-lit modern life cannot recreate. You don't need to believe in any of this. You just need to make contact. The mechanisms work regardless of whether you know their names. The electron gradient moves through bare feet on grass, whether or not you've heard of Clinton-Ober. Ultraviolet light converts 7-dehydrocholesterol into vitamin D3, regardless of your knowledge of Michael Holick. The body runs the chemistry without waiting for you to understand the physics. It operates the moment contact happens. Now, return to the image of your bare feet on grass or soil, feeling the cool give of real earth. That contact isn't just one effect. At least 6 different physical processes happen at once. An electrical circuit completes between 2 oppositely charged areas. Soil microbes interact with your immune system through skin and breath. A photochemical reaction happens, converting sunlight into a hormone precursor across your skin. A visual field of gentle stimuli allows a tired attention system to recover. Airborne plant compounds affect immune cell activity, which can remain elevated for 30 days. A mechanical recalibration runs through 26 bones and 100 small muscles that modern shoes have muted. Most of this won't produce noticeable sensations. You won't feel the electrons or bacteria. You might feel warmth and the texture of grass on your skin, along with a kind of quiet that's hard to describe. This quiet has a mechanism. It took physics, immunology, neuroscience, and biomechanics much of the last century, mostly working in isolation, to discover it. Consider how strange this isolation is. C.T.R. Wilson was studying atmospheric voltage gradients in Cambridge in the 1920s, unaware that 80 years later, a biophysicist in Los Angeles would be examining red blood cells to see if that same voltage gradient could be absorbed through skin. Christopher Lowry tracked serotonin neurons in mouse brains without knowing his findings would eventually link to immune cells in office workers walking in forests near Tokyo, inspired by a public health campaign initiated by a Japanese ministry. None of these scientists were working toward each other. They simply followed rigorous, narrow questions in their own fields, using available instruments like multimeters and microscopes. Each independently reached similar conclusions. The human body behaves differently when it is in direct contact with the unmediated Earth compared to when it is not. It's worth reflecting on how recent this removal really is. A person born in 1920 likely spent a significant portion of early childhood with bare feet on dirt, garden soil, or unpaved yards. Rubber-soled shoes didn't dominate global markets until well after World War II. Synthetic flooring, elevated living, and air-conditioned environments became widespread even later. In contrast, a person born in 2020 may go for years without their bare skin touching anything but floors, fabric, and screens. This is not a difference measured in evolutionary time. It's a change seen over just 2 or 3 generations. A single lifetime filled with architectural and material shifts layered above physiological systems that took hundreds of thousands of years to adjust to a very different environment. You don't need to believe any of this. You just need contact. The electron gradient travels through bare feet on grass, whether or not you know Clinton Ober's name. Ultraviolet light changes 7-dehydrocholesterol into vitamin D3, regardless of your familiarity with Michael Holick. The serotonin neurons in your dorsal raphe nucleus respond to soil bacteria even if you don't recognize Christopher Lowry's name. The body isn't waiting for you to understand the physics. It simply executes the chemistry, electrochemistry, photochemistry, and mechanics as soon as contact is made. This has been true for every human who ever lived throughout the span of our species, except for this brief, strange, insulated moment we are experiencing now.